Hello, I'm Sean from BigRep, and welcome to our first episode. My voice just cracked. It's like I'm in puberty.
Hey,
How are you,
hi.
Marco?
All good. Thanks,
Good.
Sean.
So today we're going to talk a little bit about moving from desktop to industrial additive manufacturing and what goes into designing industrial parts that's different from desktop parts.
Right. So today I would say we just start a bit with the basics, right? One of the first point maybe I will touch, it's probably how to save as much post-processing, right? This part has been designed for FDM. It's a fixture for a car to just place, the logo of the car in position. It's just to show a user case. And you can see like how the details have been optimized, again, for FDM, right? You tend to not have a standard handle that you would have had if this one was, injection molded. You probably would have had a handle of 90 degree, straight up 90 degree, like a standard handle. But if you don't need to have that strong gripping and you can redesign it a bit for FDM, like twisting this angle, which still you have the grip enough to hold the fixture in place on the car, but you save all the printing time of the support and the post-processing, and also here inside this angle, you see there is a little gap, which is still rounded, and this it allows you to remove basically all the support. In this case, of course, still you had some support in between the gaps where the letters go. You cannot really avoid that because it needs to stop the part in that specific position. But again, you can, of course, remove as much support as possible, but sometimes it's necessary and you have to keep it.
So we know that it's important to minimize post-processing and to reduce the amount of supports that you're using, but how do you do that when you need to print an object that has, let's say, large overhangs?
If you consider the overhang, sometimes you can use it to actually reduce the amount of support, right? First of all, you need to know what's the overhang angle maximum of the material you're using. There are some material that actually push the limits kind of a lot, like our high temp, for example, material, which has an overhang of 60 degree, which compared with 45 degree of PLA, it's already much more, and it allows you to have, like much more inclined angles without using any support, and that's already, a big benefit. And on the other hand, I will use this one as example. Sometimes, like little details can really affect the amount of post-process you have to do removing support. Okay, consider desktop printers, right? You have a small printer. If you have a certain amount of support, let's say it's a 100 grams print, and then you have 20% of it's support, then you have 20 grams of support. But when we go in a 1 cubic meter printers and you're printing something that is 10 kilos, then 20% of 10 kilos is much more.
Becomes a lot more support material used.
So it's a lot of support that you want to save. First, to save the printing time, but second, also the amount of material you waste, let's say, because in this case, we're talking about breaking down support. So little details, like, let's say, this object, of course, has been printed like this, right? It's pretty clear, so it doesn't have much support or no support at all. But let's assume for some reason this part would have been printed like that, and this part would have been 1 meter high, right? You would have support just for this surface all the way up to 1 meter, just to hold this little surface. Now, if it's necessary to have the surface like that, well, of course, go ahead, you cannot change it. But if you're designing it for FDM, doing a chamfering, right? So chamfering this angle here, this surface. So
what
basically,
is chamfering?
Chamfering is just a simple command that is in all the CAD design software, which basically change a 90 degree angle, for example. Like in this case, from this surface to this surface, bottom here, it's a 90 degree difference. And if you select this edge and you do this chamfering, and then you give the right distance, which is probably this distance inside, it will convert this 90 degree surface to a 45 degree surface. Now, as I said, for example, for high temp, you can also go, being the overhang 60, we can also go 30 degree, right? So it's not flat, it's a bit inclined, but this will make sure that all the support from bottom until there, it will be saved.
Even with a PLA material?
With PLA, in that case, you should have at least 45 degree, right? With high temp, you can go 30 degree. So it's closer to having a flat surface, a bit inclined. But if it doesn't affect the function of your part, right? Let's say in this case, for example, it needs to fit inside, right? But having an angle here, it will still make sure that the part locks itself. So it will still work, but in the same time, you will have saved this amount of time, right? And we're talking about 1 meter high.
Yeah.
So it starts being a lot
Becomes
of
worth
support,
it.
right? Yes, exactly.
Thanks for watching this episode of BigRep Academy. Be sure to subscribe to see all the new videos we release and get all the design tips you need for industrial, large format additive manufacturing.